Hello. Hello. Yes, thank you. Thank you all for coming to this. This is my technical talk. I have a more kind of silly, fun talk tomorrow, same time this room. So if you're expecting that, run. This is a proper technical talk about diagnostics and metrics and tracing and all that kind of good stuff. I'm Mark Rendle. I have a company called Rendle Labs, which is just me mucking about with stuff and then putting it on GitHub. And at some point, something's going to happen and people are going to start giving me money. Still trying to work that bit of it out. You can follow me on Twitter at Mark Rendle. And if you've got any questions or you go off and you try to implement this, then please do feel free to reach out to me on Twitter or anywhere else you can get hold of me. I always like to help people do good stuff. So, I pop up at NDC most years, go to most of the different conferences, and I always seem to be talking about something different. And this year, I'm talking about diagnostics and metrics, and I thought it was probably worth talking briefly about why. So this whole kind of thing with me getting into this started about this time last year. One of my customers was having a problem with a piece of software that was being much slower than they thought it should be. And they said, can you help make it faster? And I said, yes. And so I sat in on the first meeting where they were discussing how they were going to make it faster. And people were saying, well, I think it might be this that's slowing it down. It might be this, we might be leaking some memory somewhere. We might be doing too much garbage collection. And so people had been guessing what was wrong and then trying to fix it and optimize it and everything else. And I said, have you actually measured what's going on when this process is running to find out what's, how long each different sub-part of this process is taking? And they said, no, do you think we should? And I went, it couldn't hurt. Why don't I add some instrumentation to your code and we can sort of add up the bits and everything. And so I did that. And then I showed them the kind of metrics that I'd gathered out of this, and they looked at one of these things that was happening about 20,000 times every process, and they went, what's that? And I went, it's doing a lookup against another service. And they went, no, it's supposed to batch 20,000 IDs together and then send them all to that service, and then it sends all of those results back in one go. But it wasn't. It was opening a connection and doing one request and then closing the connection again and then opening the connection again. And once they fixed that, it knocked about a minute off the time that the thing was taking. And they had no idea that this external service was being hit all these times. And so that's what the whole point of metrics and tracing and diagnostics is about. It's about having visibility into what your system is doing, specifically in production. Because no one had picked this up in dev or in QA or testing, because in testing they didn't look up 20,000 things, they looked up 20 things. And so that didn't really have a noticeable effect. It was only when it got into production and started dealing with actual data that this started happening. And this wasn't, see, metrics, diagnostics, all the dashboards and everything else that you see, you tend to associate them with this new kind of microservices and distributed web applications and all that sort of thing. This wasn't that. This was a WPF application running on the desktop. But I used the same technologies and the same techniques to add the instrumentation to it as I would have done if it had been a .NET Core 2.2 application running in a Kubernetes cluster in Google Cloud. So this is relevant to everybody, whether you're writing .NET desktop applications, might be Xamarin applications running on a phone. You can use the same set of techniques. Also, dashboards are cool. It's nice to be able to get up on stage and go, yay, dashboards. And so I wanted some of that for myself. So I want to get clear right at the start. There is the difference between metrics and logs, just in case anybody's not clear. Logs People are quite good at logging these days. People have kind of spun up an Elasticsearch or Loop, or they're using an online service like Loggly or something like that. And even if it's just try something, catch exception, log error, even if that's all you're doing, that's still good because it means you've got that text is going off. That's logging, that's text, and that's creating a searchable record of everything that's happened in your system so that you can go and get stack traces or descriptions or that sort of thing. Metrics, really just numbers. And numbers that you can aggregate and average or sum or window over time, things that you can do maths things with and make pretty charts and stuff. So a logging dashboard, you'll generally be able to see text in there. A metrics dashboard is all pretty lines and colors and animations and that sort of thing. And we're going to be talking about metrics in here. So yeah, metrics is very good for when you're dealing with things like performance, or how often is something happening? How long does it take when it does happen? How much CPU is being used at any given point? These are all metrics. Text, error messages, information, that's logging. And this area of this kind of, it almost feels new. Like we haven't been doing this properly, and so now there's a movement towards this. And it's referred to as APM, which actually stands for Application Performance Management and not monitoring, which I literally only discovered as I wrote this slide. I'd always assumed the M was for monitoring, but it's not, it's for management. And there's a big growth area at the moment, and I found this website, which is very useful, called openapm.io, which is got lots of information about lots of open source tools that you can use for application performance management. And you can actually go in and you say, this is my stack, this is what I'm using. So you can go in and you can say, I'm using .NET, and it will go, right, here are some libraries you can use, here's the back-end technology you can use, here's the sort of stuff that you need to do what you need to do. So that's a great resource, and I will leave you to go and view that for yourself. So, what do we want to measure? You want to measure things like how often something happens. You want to measure how much stuff is going through your system, and that could be number of requests or number of objects or number of bytes, depending on the kind of system that you're writing. It could be how many records did I get back from the database, or it could be how many bytes were returned from the database that then broke down into those records. It's timings. So if I start a timer and then do my database query and then stop that timer, how long is my database query taking? How often are errors happening? How often is each kind of error happening? So yes, in your logging system, you've got a thing that says there was a null reference exception because we haven't got C#8 yet. But in your metric system, in your dashboard, you can go, right, over the last hour, there have been 1,500 null reference exceptions, one not implemented exception, and one exception that I've never even heard of, and I'm scared now, and I want to go and be a farmer. So you can see the number of errors that you've got going through there, and you've got system data. So system data is stuff like, what's the memory usage like at the moment? What's the disk I/O, the network usage, and so forth. For web applications, you're going to be looking at stuff like requests. So how many requests per second are you serving? And then you can cut that up and group it by how many requests to this page, to this controller, to this area of my MVC application. What are my response times like? What are my status codes going out? So how many are 200 and how many are 404 and how many are 401? That sort of thing. What kind of errors are happening? Database or upstream HTTP requests. Upstream, I just had a conversation with someone who said, someone said it was downstream. So downstream is what's calling you, upstream is what you're calling, okay? Yes, it is. I'm not arguing about it. Native applications, and this is the thing that I was working on, it's things like startup time. So if you've got an application and you want someone to double-click an icon on the desktop or tap an icon on their phone, then that application needs to load really quickly as it possibly can. And so measuring things like startup time is very useful. And then when you release a new version of your software, you can immediately see from the dashboard, you can overlay the new version and the old version of the software, and you can go, oh God, we've slowed down. It's taking an extra second to start up. What's happened there? And go and look into that. Things like feature usage. So you can get feature tracking as a kind of high-level feature in some monitoring software. But you can just say, OK, I'm going to create a thing that says this is how often they used invoicing, this is how often they used the contact database, this is how often they used that. Just general performance. So how long does it take to navigate from one screen to another screen within your application? How long does it take to calculate a total or to populate a grid? And then the same stuff as web applications. System data, so you want to be monitoring things like CPU time, because if that goes up near 100, then things are probably bad, and you're likely to stop working fairly soon. But at the same time, if your CPU is consistently running at 1%, then maybe your server's too big, and you could get away with downsizing it to T2 micro, or something. Memory, you don't want to be running out of memory. Disk, network, I/O, and now the Common Language Runtime, and particularly in .NET Core 2.2, there's a whole lot of information that you can pull out of there, which I will hopefully have time to touch on towards the end of the talk, about things like how many garbage collections are happening, how many objects are going to Gen 0, Gen 1, that sort of thing. What's the thread pool doing? How is the thread pool count gone past what we've set as the maximum? That sort of stuff. So, how to measure. And this is the fun bit, because there are lots of libraries out there that you can get. There's a great library that I like using for my web applications and my .NET Core applications called AppMetrics, which Martin has done a talk or is going to do a talk about. AppMetrics is brilliant, but there is a problem with that, because if I say I want to use AppMetrics, then I need everyone else who is contributing to my overall system to say, yes, all right, we'll use AppMetrics, and then we can all hook into the same thing. The company where I was putting in this software, this instrumentation into their software, uses Gibraltar Loop, which is a really nice, if you're in .NET, then Loop is a really nice logging and metric system combined, it's done by Kendall Miller, who is around somewhere and doing a talk about how CPUs work tomorrow. But yes, in this team's area of this big organization, they wanted to use Loop because it was the most appropriate thing for them to use. But not everybody wanted to use Loop. And this is a big organization. This is like 10,000 developers working in lots of different languages and thousands of developers working in .NET. And so they've got shared libraries. They've got teams whose whole job is just to make libraries for the other teams to use. So if you want to use Zookeeper, then you have to use their Zookeeper library to talk to their internal implementation of Zookeeper, because they're using Kerberos authentication or whatever it might be. So they've got lots of different teams making lots of different things. And so you can't go to a team who is making a library to be used by 50 other teams and say, hey, can you add support for this logging system that we use? We're fully aware that nobody else in the organization uses it, but we really like it, please support it. Because they're going to go, no. Because if they had to do that for all 50 of the people, all 50 of the teams, then they'd just be running around in circles trying to support all these different things. And so I was reminded of something I'd seen mentioned during the whole .NET Core, ASP.NET Core stand-ups and everything, called DiagnosticSource. And this is, it's built into .NET Core, but it's available as a package on NuGet. There's a Net Standard 2.0 version, there's a Net 4.6.1 version, because now we have separate Net 4.6.1 versions for things, because it turns out it doesn't implement Net Standard 2.0. But it's built in. And so it's not like you're taking a dependency on an external library. I mean, we had this with logging as well. Who uses, is it common.logging as an abstraction? So as an organization, you go, we'll standardize on common.logging. And then if I want it to go to nlog, it can go to nlog. If I want it to go to serilog, it can go to serilog. And it's kind of, yeah, okay, so we've got that, but you still have to get people to agree on that thing. And that's actually easier now that there's Microsoft.extensions.logging, because all organizations are happy to take dependencies on Microsoft packages. So yeah, let's use Microsoft.extensions.logging instead. This is the same sort of thing. You're going, it's a Microsoft package. Look, it starts with system dot. It's signed with the Microsoft key. You don't have to put it through security operations and all this sort of thing. And so I thought, can I put DiagnosticSource throughout the code and use that as an abstraction over logging? So that's what I did. So it's part of the .NET framework, and it basically has three capabilities. You can write events to it. You can trace activities, so you can say, I'm starting an activity, and you can go off and do a bunch of stuff, and you can say, that activity is now finished. And then at the other end, you can listen for events through DiagnosticSource and say, I'm going to do something with this data that's coming through here, which is all you really need. Now, you might be thinking, you just described trace. And I sort of did, except the thing with trace is it's strings. Again, trace is great for logging. You can write things to system.traceSource or diagnostics.trace and then pick that up and write it there. DiagnosticSource works with objects, works with structured data. And so it's much more geared towards the metrics and diagnostic side of things. So, writing events is really simple. You create, there's some dodgy stuff going on under the covers to make this as easy as possible to use, okay? But essentially, you create a diagnostic source. Now, you'll notice here, so you've got a diagnostic source, which is what you write into, and you've got a diagnostic listener, which you imagine is what you're going to listen to at the other end and write that data out to somewhere. Except when you create, no, that button. Yay! I got a new pointy thing. So yes, you create a diagnostic source, but you create a new diagnostic listener. So that's interesting. But whatever. You create a diagnostic listener, but you assign it to a diagnostic source. And you have to give that diagnostic listener a name. And a fairly good standard for that is to say, use the full type name, including the namespace, of the class that I'm generating these diagnostics from. That's fine. Now, there is an issue here that you don't want to be generating these diagnostics if nobody's listening. And particularly if people are putting these in upstream packages that you're pulling from your internal artifactory or whatever it might be, you don't want to, this is in system code. This is in like low-level parts of libraries. And so if nobody cares about the diagnostics, you don't want to be generating the diagnostics. So we have a diagnostic source which has got a name, and then we have a name of an event on that diagnostic source. So you can have one diagnostic source with multiple events happening on it. And before we write anything to it, we say if diagnostics.isEnabled, main, then diagnostics.write, main, new argcount equals args length. Because this bit here is an allocation. And if you want this going into something that's doing 20,000 requests a second or one request of 20,000 things a second, if you want this put into your software at the lowest level, you don't want to be allocating objects unless you actually need to. And I'm going to come back to that in a bit because people always ask for syntactic sugar around this, and it looks like it should be possible, but the obvious way of doing it is not good. And then we have activities. And activities, DiagnosticSource was around for a while, I think it was on 4.3 point something, and then they added activities onto it. And activities, they do something in a specific way, but they provide an extra layer of cleverness on top of that. So we'll look quickly at how you use an activity. So we say if diagnostics, so it's still just a diagnostic source, and we still say, is it enabled? And if it is, then we create a new activity. And we say, this is where we're going to put the name of this event here. And then we say diagnostics.startActivity, and we pass in the activity that we just created and some arguments. And then we do something, and then we have a try finally here, and we have a diagnostics.stopActivity. And this automatically does stopwatch resolution timing of that, that operation so that you can see how long things are taking. And it does something else useful as well, which we will come back to again in a little while. So I'm just going to show you quickly some actual code, because code is always good for these sorts of things. So I have got, you can go away. Is that big enough? Can everyone see? Yeah, good. Right, so I've got just a simple ASP.NET Core application here. What this actually does, it exists for a different purpose. You give it a URL, it goes to that URL, downloads the HTML, sees if it can find an OG image or Twitter image meta tag at the top, then goes and gets the image that it points to if it's there, resizes it to a size that you specified, compresses it to JPEG and returns it back again, which I couldn't find as a pre-existing service, so I wrote it. And so this is what's going on here. So I've got my controller, and up at the top here, I've got a diagnostic source. Now, these things, not only is it fine to make them private static read-only, that's actually what you want to do, because otherwise you're going to have multiple listeners attached to multiple instances of the same diagnostic source, and you'll end up thrashing memory and garbage collector and everything else. So just create a static instance and use it over and over again. It is thread safe for reasons that we will also come back to. And then we go down to here, and we say, so I'll take that out for now, and we'll just look at this one. So if diagnostics is enabled, image resize, so if somebody is listening and doing something with this information, then work out the original length of the original size of this image, work out the new size of the image after I've compressed it using image sharp, and then write that out to diagnostics, and so I know the amount of space I've saved, or the amount of bandwidth, that's the word, the amount of bandwidth I've saved processing this request. So that now goes off, and that could be picked up by anything. I might have one listener on there that's just sending that off somewhere, or I might have half a dozen listeners sending it to different places. I might have some diagnostics going to one place and some diagnostics going to another place. It's a proper in-place abstraction that separates the producer from the consumer and leaves it entirely up to you how you do the consuming side of things. So to make sure that actually goes somewhere, I have to come to here. So I've got a console monitor. This is the simplest possible level for this. And if I go into console monitor, this is a hosted service. So if you're not familiar with .NET Core 2. whatever, you now have essentially something that will just run in the background of your application doing useful stuff. So it's a great place for putting things like syncs for logging or metrics or whatever else. So when this starts up, we have a two-step process. We say diagnostic listener.allListeners. This is a static property on the diagnostic listener type. and it is an iObservable. You don't often see iObservables in first-class Microsoft APIs, but we've got one here. So you attach to this, and you say, whenever a diagnostic listener is created, whenever a diagnostic source is created, let me know so I can decide whether I want to subscribe to it. And so you then say, every time I get one of these through, what I'm actually getting here is another iObservable. Diagnostic listener is an iObservable of key-value pair of string object. And so I'm going to subscribe to that as well, and then I will get fed things off there. So yeah, I can do stuff in here to do things like, I could say, if source.name does not, or dot starts with, Rendle labs dot. So I could put that in there and say, only subscribe to things that are my own namespaces, so I'm not picking up stuff from other people's things. If you're building a library, then it would be nice if you did use whatever namespace. So if JSON.NET wanted to put diagnostics into the JSON.NET library, then hopefully he'll start them with Newtonsoft. And we can listen on that as well. And in this instance, I'm just going to say log that output to the command line. And so if I go into here and do .NET run, OK, so that's listening on there. And then I can, no, not you. This is just something that generates traffic. And then I can go back over here, and then I'll just shut that down. So because it's using log, it's actually making it look quite a lot like the log. But you can see here, so this is coming from Rendle Labs meta image diagnostics console monitor, and it's written out the name of the source, the key, so the event name, effectively, and then I think I've just serialized the values off. And the original size was 563K, and the shrunk size is 32K. So that was obviously a massive and badly compressed image the first time round. So that does that. That's fairly straightforward and obvious. Any questions about anything so far?
How does it know whether you're listening?
Because when you call the subscribe method, let's just go back. No, it's in the code, isn't it? When I call subscribe here, so I've got source, I'm using the reactive extensions here. None of these will actually do anything. It's kind of like, if you're not familiar with reactive, you know, if you create an async, you create an IEnumerable method, and then you call it, and it doesn't actually do any of the code in the method until you start enumerating over it with for each or to list or whatever. This is the same thing. It won't start doing anything with it until you call .subscribe on the iObservable. As soon as you call .subscribe, it sets a flag inside the diagnostic listener to say, yes, someone is listening to you. And when you dispose that, if all the streams dispose that, then it will shut it off again and say, it's all right, nobody's listening anymore. With things like dynamic configuration in .NET Core, where you can kind of go in and change a value in console or Zookeeper or a text file if you must, you can actually say, when that changes, disable metric. So you can turn it on and off while your system's running. And because there is obviously a performance hit to doing this. That's why we don't want to do it if nobody's listening. But you might have really low level, I need to get some information out, but I don't want that performance hit on a day-to-day basis 24/7. And I've lost my slides. Okay. Shift F5. So this therefore gives us a mechanism where we can say, write to diagnostic source. Don't worry about that not being supported. It's as close to being actually in the .NET framework as it could possibly be. Is there anyone in the room whose company will not let them install NuGet packages from Microsoft, signed by Microsoft, supported by Microsoft, that are maintained inside the .NET/CoreFX repository? No, not really. But yeah, so this is baked in properly, and it is part of .NET Core in particular. So it's supported by some of the stuff inside .NET Core and ASP.NET Core. It's supported in ASP.NET Core. They will say, we are starting processing a request. So right at the hosting level, Microsoft.ASP.NET Core.hosting, as soon as it comes off Kestrel, it says start an activity, which is processing this request. And then once it's finished writing the response back out again, it says stop that activity. And you can hook into that and say, how long is this taking actually at the lowest possible level in the framework? Because by the time, you can put a start a timer and end a timer in your controller method, and that'll tell you how long your controller method took to run, but I don't think I need to tell anybody that how long it takes your controller method to run and how long that actually took on the server are not the same thing at all by the time you've got things like caching and compression and all the various other parts of the pipeline and the middleware and everything else that's going on. So because we've got this standard way of doing this, in the same sense that Microsoft writes a ton of stuff to the logs, do not put something into production with logging set to information for Microsoft or system namespaces, because you will run up a bill of many millions of pounds in Splunk in about a week. But it's useful to have it. It's nice to have it there. And diagnostics gives us the same thing for this structured data, this useful maths type data. Entity Framework Core has it in there as well. So Entity Framework Core will say, I'm starting an activity, I'm running a query against the database, the query's returned, I've serialized all the data back out again, I'm stopping the activity. And so you can hook that in there as well. And because it's got this object that you pass in with all these different values on, ASP.NET Core gives you the HTTP context that it's using for the duration of that request. Entity Framework Core gives you the DB connection that it's using for the duration of that request. It gives you the DB command. It therefore is giving you the SQL that it is running against the database. Even better than those two things, though, is that HTTP client supports this. So this is system.net.http client. Doesn't matter where you're using that from, it supports DiagnosticSource. And we'll have a look at why that's really cool now. Because there is another issue with gathering these kind of metrics. We are building big distributed systems. Who is working on a system that runs across multiple machines and makes requests to other services on your intranet or on the internet or anything, anywhere else in order to process a single request? If you're not now, you're gonna be within the next couple of years. Or get another job. Because trust me, it's cool. It's so much more complicated. You can charge so much more per day for getting these things to work, and you look so much cleverer at the end of it. You really do. But this has introduced this problem of distributed tracing, and Aaron Stannard was talking about this with regards to Akka.NET. Now, obviously, Akka.NET is an actor system, and so the whole point is that you've got dozens or hundreds of machines, and you're just farming out requests and going, I don't care who does it, somebody do it, get back to me when it's done. And so you want to be able to correlate all these things together when you get them back again. when you're looking through the logs, you want to go, right, so this exception happened, but what request was that processing, and why was it doing that, and trace that right the way back up through. And there are platforms like Jaeger and Zipkin, which are designed to manage the data that you get out of these things, where you have request IDs and spans, and so you can say, right, so this happened over here, and this happened on an arbitrary machine, I don't really care which one, and then it made 3 requests to 3 different services, and I can still see that they were children of that because they're sharing a correlation ID across all these things. And ASP.NET Core, because it supports this diagnostic source and this activity thing, actually works with that internally. And there is some very clever code in there. There is something called the HTTP correlation protocol, which makes it sound like it's a standard. And it is a standard in Microsoft. But it is something that the W3C are working on, because this is becoming a global problem, and we need a global solution, and it would be nice if everything talked the same language and used the same solution. So at the moment, Microsoft have got their own, but it's adaptable. They can change it if they need to. So ASP.NET Core, when it starts processing a request, looks at the request headers and says, have you got a request ID? And if it has, then it goes, cool. I don't care what that is. I'm going to generate another random string. It could be a GUID, or it could just be datetimenow.tix or something. And I'm going to tack that on to the end of this request ID. And so whether that's going to Jaeger or Zipkin or something else, you'll be able to correlate these requests together and see them grouped into the overall thing. And it also has a correlation context, because you might have various tags. You might want to say, okay, so the product ID that we're working with, over on the first server that started processing this request, it knows what the product ID is. It may be that the product ID is not one of the parameters that it's passing on to another service. It might have gone and done one lookup already and got back a user ID, and now it's going to the user service to say, what's this user with this user ID? But you can pass across the product ID that was originally specified, and activity provides a way of doing this with something called baggage, which we'll look at briefly. And so, even better, actually, I've got the code for where it does this. I'll just drag that up quickly. So this is where Microsoft, the ASP.NET Core team, are doing this inside the hosting service. And they've got other ones of these for things like executing a view or whatever it might be that they're doing. And so you can see they've got this request ID header name, and they've got activity name and activity start key. They've got some deprecated keys. It never even made it into proper production before they had some deprecated keys. If you are planning on actually working with the diagnostics that they generate, get used to diving into the code and digging around and finding out what they are, because that is literally the only documentation there is at the moment. This is a known issue. People are supposed to be working on it. When I said something yesterday, David Fowler went, pull request. I go, yeah, OK, I'm not busy. I may actually do it. So yes, when this is the point where the request starts being processed. And so you can see here, we say if diagnostic listener enabled. So it won't do this if you don't have a listener set up. It's not going to do it at all. And that means the weird thing with that is you might not be doing anything with the data. But if you want it to do this request correlation ID thing and pass it on to upstream stuff, you need to attach a listener, otherwise this code won't happen at all. They're talking about maybe reversing that, so the default is that it does it and there's a switch to turn it off, but at the moment, even if you're not actually listening, you need to pretend to listen to make it do this. We say start activity, and if I go down to start activity, I don't have a definition found, because this is the new ASP.NET Core mono repo, and there was no way I was going to do .NET Restore on that on the conference Wi-Fi. You can thank me later. So where are we? Start activity is down here. So we're going to create a new activity with the activity name. We've got this request ID, which we tried to take off the headers. If it was there, then we're going to say activity.setParentID to this request ID, and then that will cause the activity, when it is started, to generate a sub-ID off that. And we're also going to split out the correlation context into an array, and then if there is anything there, we'll add that to the activity as baggage, so that gets passed through. Now, I'm not going to dive into the activity code because it's a bit gnarly, but there is an activity.current static property, because there's no standard way of passing something around. There's a standard way of passing things around in ASP.NET Core. You've got the HTTP context, and actually they do attach the activity to the context, just in case. And you have dependency injection, but you don't necessarily have that in UWP or Xamarin, for example. So they are using an async local context for the current property. And if you don't know what that is, it's like thread local. So thread local creates an instance of a static property for every single thread. Once it's been created, it sticks to that thread and it just stays there. Async local does the same thing, but within an async. So if you do await on something, then when it comes back, whatever thread it gets rehydrated on, it will still have that same value on there. And so activity.current will follow you through an entire set of async processes, and it will always point to the right activity. And so you can say, when you say start a new activity, its default behavior is to go, is there an activity.current? If there is, set this new activity's parent to the current activity, set the current activity to this new activity. Leave it like that until we stop the activity, which is why it's so important to do it in try-finally blocks, and then set the current activity back to the parent of whatever this activity was. Did that make sense? Yes. Good. Excellent. I'm very happy. The reason that this is incredibly useful, and the reason that you want it to be happening, even if you're not actually listening to the things and writing them out anywhere, is that HTTP client does the opposite of this. So HTTP client, when you say get async or get string async or post or whatever you might do, looks at activity.current. And if it says, oh, look, there's a current activity, then it takes the activity ID off there, and it takes the baggage off the current activity, and it puts the request ID and correlation context headers into the request that it's sending out, and then passes it on up. And also has the side effect that it's timing your HTTP request for you from right inside the framework, which is pretty neat. And so you've got this, I'm hoping we're at the kind of early stages of this process, where we've got this level of metric gathering and information provision inside not just ASP.NET Core, not just Entity Framework Core, but actually inside .NET Core itself. And at the moment, it's just on HTTP client, but you can see it going into more things. One thing, when they put, finally, Microsoft.Windows or System.Windows, the WPF source code, as opposed to just XAML, which is all we've got so far. When they put the WPF source code on GitHub, I'm cloning it, and has anyone ever used the binding trace source, which just spouts text off saying there was a binding error, and there's no consistency in the format of those errors. So I have to write a parser, and you have to write multiple parsers for all the different errors and so forth. And I'm going to go on my first pull request to WPF is to create additional versions of those that put that out as structured data over a diagnostic source. So you can just go listen for binding errors on the diagnostic source, and it'll actually have consistent source names and value names and field names and whatever else might be in there. So yes, but basically, if you get a request in, if you've got these diagnostics turned on, if you get a request in and it had a request ID, then it'll automatically be put into the current activity. And then if you make an HTTP request with any HTTP client at all, then it will pass that request ID on plus your little sub bit to say, this is now part of this process. And all that's just handled for you. And it means that you can do it as well. HTTP client is doing that here. So it's got a delegating handler that it uses, diagnostics handler here. And yeah, so it says, where is it? Activity, current activity equals activity.current. If it's not null, and you haven't already put a request ID in, because obviously it doesn't want to be coming along and overwriting your request ID, then it will serialize this and put it into the new header. So that's in there as well. That's in system.net.http, and it's part of the core FX repository. So it is as close to being part of the base class library as you can get without actually breaking .NET Core 4.8. No, .NET full fat 4. What are we supposed to call .NET now? Because you can't .NET classic .NET. This is what the correlation protocol looks like. Request ID starts with a pipe to say, this is definitely the start. I haven't just forgotten to give you the start. This is the start. If the pipe's not there, then it's probably me being stupid. Then there is the root request ID, which is this one that starts with 9823. And then it ends with a dot. And again, it has to end with a dot. There are two great things about it ending with a dot. One is, actually no, there are three great things about it ending with a dot. Surprise, fear, and a ruthless efficiency. Monty Python jokes. I didn't expect, no. I've forgotten myself. No, so three good things about it ending with a dot. One, you definitely have ended it with a dot. That's on purpose. It hasn't just been cut off at some point. You haven't overflowed the maximum length of a string. The maximum length of this, by the way, is 1,024 characters. So yes, you know it ends there. It means when you're adding on to the end of something, you don't have to do that thing where you go, if there was something there before, then append a dot and then append this thing, otherwise just append this thing, because you're not prepending. It's fine for there to be a dot on the end as well. But most importantly, if this goes into some kind of searchable database and I'm going, this ends with 42 dot, I can search on .42 dot and find those things. If I search on .42, I'm going to get everything that starts with .42 as well. So it makes that nice and easy. And then we have the correlation context, which is just a string of key value pairs done as a comma delimited list. So we've looked at reading events using the monitor, but before we finish, I just want to show you, oh, hang on. I'll show you the one other thing that we didn't cover. So, in my image controller, this, writing diagnostics dot is enabled, then do this and create a new thing, is strenuous. And so you might find that people, well, one bad thing they could do is just assume it's going to be enabled and not bother checking because they can't be bothered. And the other possibility, which is much worse, is that they just won't put diagnostics into their code. And you don't want that. So you want to make it nice and easy for them. But there is a problem. And I will show you the nature of this problem using SharpLab. So what I've got here, if you haven't used SharpLab, by the way, it's sharplab.io. You type in C# code on one side, and on the other side, you can get it to show you what that C# code turns into, but also in C# code, or you can get it to show you the IL, or if you run it, you can get it to show you the machine code that the JIT put out, which scares the hell out of me, and I don't do it. But yes, so people go, oh, we could create an extension method. Just write if enabled, and then that saves lots of time. I can just say DiagnosticSource.write if enabled, and then this is nice. The problem here, though, is that you're saying, call this write if enabled method, create this object and pass it into that method. So you've completely missed the point of is enabled. So please don't go and think, aha, clever, I'll go and do this. Because the whole point of having the is enabled thing is to say don't create objects unless you absolutely have to. But because it was so tempting to actually do this, I did manage to figure out how to come up with a syntactic sugar that's almost nicer. So we created an extension method called, this is a simplified version. But if we go and look down here just quickly, so yes, you can see ds.writeIfEnabled, foo, new global anonymous type, etc., etc. Instead, we created an if-enabled extension method, and if the diagnostic source is enabled, it returns the diagnostic source. Otherwise, it returns null. And this question mark dot would be good, wouldn't it? Okay, so diagnostic source dot if enabled question mark dot write. So we're using the null dereferencing operator. What that actually compiles to, and you can see that down, so it's still roughly the same, but what that compiles to down here, if I can find my M method, is diagnostic source equals diagnostic source dot if enabled. If it's not null, then call write and do the new process. And so we do actually have this essentially desugars to what you should be writing, and it does it really nicely. The only problem with that that I really didn't like was you're saying if enabled foo dot write foo. And I was kind of like, I'm writing foo twice. Why am I writing foo twice? And I was watching somebody do a talk about something, and I thought, oh, I could do that instead. So let's move that out. So now I have an extension method that says diagnostics.ifEnabled image resize .write, and it just knows that it's image resize. And I just want to show you how that works because it was weird. Because obviously that's using the null dereferencing operator. So I need something that can be null, which means I need to create an object. Except if I create an object, then I've just done that allocation that I was trying to avoid anyway. So it would be much better if I could create a struct, because then I don't have an allocation and I can just put the diagnostic source and the name into the struct and then put a write method on that. Except then I can't use the null dereferencing operator, except you can use the null dereferencing operator on a nullable of a struct. And I'm not sure how nullable is a struct, but it is. They've done something nasty. I once tried to recreate nullable, and I couldn't because there's something weird going on in the base class library to make it work. But anyway, so I've got a public read-only struct, maybe diagnostic source, and my if enabled returns a nullable of that struct. And now that works, I only have to type the name of the event that I'm writing once, and I've still got my lovely syntactic sugar. Don't worry about grabbing photos of this because I'm going to do a git push as soon as I've finished and just take a picture of the last slide, which has got the GitHub URL on it. So yeah, that was fun. So then you want somewhere to write this through to. I've actually submitted a pull request to Loop. Loop has now got an open source agent for .NET Core. And I was kind of like, this is really cool. So I sent them a pull request that made it pick up all the ASP.NET Core and Entity Framework Core diagnostics and write those out. But I like writing them to InfluxDB. Particularly because this is a desktop application running on desktops. InfluxDB, if you don't know what it is a time series database. It is optimized for writing items, numbers, to a stream with a timestamp and then running queries against them. And there are two main popular time series databases right now. There's InfluxDB and Prometheus. And the difference between them is that you send data to InfluxDB, whereas Prometheus comes to you and asks for data, which is called scraping, which is brilliant in a microservice environment because Prometheus will go, hello, can I have some data, please? And if the service doesn't say, yes, you can have some data, then Prometheus goes, that service has crashed. It stopped talking to me. Which is great and very useful. Influx is much more traditional, hey, take this data and store it for me. When you've got desktop machines all running, like 500 of them all running a WPF application, you don't really want to be going, can we open a port on the firewall so that this Prometheus server can spread out connections to 500 PCs and pull data back? So Influx, it's incredibly easy to write to Influx. It has a line format where you just have the name of the measurement and then comma-separated key-value pairs for the tags, and then a space, and then comma-separated key-value pairs for the fields. So tags are for grouping and filtering, and fields are the actual data. And then optionally, at the end, you have a timestamp. And so I just have to take the various names and the object that is being passed through, and potentially something off the activity, and translate that into this format, and then write it off to InfluxDB. And I did this initially using the official InfluxDB C# client. Every single line that it writes to this array, this byte stream of UTF-8 encoded text, every single line it was allocating 5 dictionaries. And you just go, this is not, when you put the diagnostics in, you don't want them to make things worse. Why is this running slowly? Because you're measuring it. It's just too quantum. More quantum tomorrow. That's just been hurting my brain. Come for the quantum, stay for the ow. So yes, I went, sod that, and I went off and I wrote my own Influx client. And I keep meaning to sort of send them something, because it's not a pull request, it's basically a your code's shit, here's some better code. Not sure how to phrase that. Probably not like that. So it's not quite ready for putting on NuGet yet. I'm still tweaking it around the edges. But it's in the example code that I've got for this application. So let's close all of those. Yeah, go and save that. So in my startup, I'm going to comment out that line, and I'm going to uncomment those lines and do that. And then I'm going to pull this down here and run that again. But yes, I don't think I've really got time to go into it, but what it essentially does is it upfront allocates a 128K buffer, and then every time something wants to write a line to it, it puts it onto a queue, and I'm using the new system threading channels. It was basically how many of the cool new things like span and memory and UTF-8 formatter and system.threading.channels and system.io.pipelines can I use in one NuGet package? And the answer was all of them except pipelines. I couldn't find a way to make that work. But channels, it's all in there. And so essentially, it just writes them directly to this chunk of data one at a time until it runs out of space, and then it sends it and starts another one. And it's all array pooled and everything. And so it's gone from 5 dictionaries plus various strings and everything being allocated for each line written to nothing being allocated for each line written other than the object which was sent to DiagnosticSource.write in the first place. So that's doing that now, and then I can go across to here and I can generate some more traffic. That's generating traffic, so that should be coming, yep, that's going through there. And then I can find here again, and I've got chronograph running. And if I hit refresh there, you can see that I've got data coming through here. So Chronograph is the kind of default out-of-the-box user interface for InfluxDB. It's great in the way that SQL Server Management Studio is great. It's a nice tool for digging around in the data and discovering it and figuring out how to build a query. What you then want to do is take that query and go to Grafana and paste it into Grafana because you want to use Grafana for your actual dashboards. But this is a nice way of doing that. And so you can see here I've got, it's automatically adding tags. That's the name of my laptop. Please don't find it on the network and hack me, Troy. Like Troy comes to my talks. That's my user ID, and we've got the activity duration, which is pulling off the activity that was created, and this is actually the HTTP request in.stop. So actually, just by adding this listener in and writing it through, this is my request timer. And I could decorate with this with some additional stuff and everything else. But this is pulling this data across quite happily, and you can see it's got various chunks of data in there. But I've also got my Rendle Labs meta image resize, and that's going to show me, so those were the original sizes, and the blue one is the compressed sizes, and that's showing me useful information as well. So I can generate that. If you wanted to use Prometheus, then you could use Prometheus. If somebody else wanted to use Datadog, they could use Datadog. My customer who uses Loop, they can use Loop. It's all there. Everybody's producing it, and some people are consuming it, and some people are maybe not consuming it. Okay, so now, fundamentally, you have no excuse not to be generating these metrics, and you have no excuse not to be storing these metrics and writing them off somewhere that you can do something useful with them. Microsoft have gone to all that trouble to make it so that you can do this. So it would actually be rude to not keep monitoring this stuff here. So in summary, measure everything. As long as you put that if enabled thing on, then you can always turn it on and off at the point where you're listening to it. So it doesn't hurt you, apart from having to type an extra couple of lines of code to go, that might take 10 milliseconds. I'll measure that. That might happen a lot. We'll count how often that's happening. Write it into a time series database like Influx or Prometheus. You can also get things that do time series into SQL Server or PostgreSQL. PostgreSQL actually has Timescale DB, which is an extension, and Microsoft are even deploying it into Azure database for PostgreSQL now, so that's quite cool. I did have one person go, can you write it to DB2? And I'm like, you can write it to DB2. I'm not sure what you're going to do with it once it's in there, but you can write it to there. Use Grafana for dashboards. I didn't have time to show Grafana, but seriously, that's what everybody uses. It's awesome. It makes you look like a total pro. And if you use it does though, doesn't it? Seriously, you just kind of go, oh, just do that. Oh, wow, that looks amazing. Oh, look, guys, I made a dashboard. Taking the rest of the week off. And yeah, use DiagnosticSource. Listen to DiagnosticSource because you never know who's writing into it. Apart from these three, I'm hoping that more people and WPF and, pull requests to stuff that's not using it. And write your own things to DiagnosticSource and go to the other teams in your organization and say, hey, we can use DiagnosticSource. We can all use DiagnosticSource, and we can all agree on it, and then we can use those metrics or not use them as and when we see fit. So that's it. This is the slide you want to get a picture of. I'll do a git push literally as soon as you've all off, and you'll be able to grab that code, including that weird nullable struct thing. Thanks very much for coming. Enjoy the rest of the day. Come back for the party later. We're doing more Monty Python things and all sorts of mad stuff. And I'll be back on here at the end of the day tomorrow to talk about the future. Thanks very much.